And today, I am glad that you could join us today to talk a little bit about PPE. Our objectives today are to provide information to help with your electrical personal protective equipment program. Now, some of these slides may contain graphic material, so just be warned that we have some pictures on here that are fairly graphic. So our agenda today is to provide an introduction to electrical hazards. I know everyone on this broadcast is probably familiar with electrical hazards, but we're going to just introduce those again. We'll look at some selected OSHA requirements because a lot of folks focus on NFPA 70E, the standard for electrical safety in the workplace, which is a very, very important and a very great document to use. But then we can't ignore the requirements listed in OSHA as well, which is law. And we may have federal OSHA requirements that may apply to your locations depending on what state you're in, and or we may have state OSHA requirements as well. So everyone here, I'm sure, is familiar with electrical hazards, electrical shock, arc flash, arc blast, thermal burns, and other. So we have to deal with that when we're looking at PPE. Of course, there are other hazards that we have to deal with as well that we're not going to cover today, such as fall protection and so forth. We're just going to focus on electrical hazards and electrical PPE. So when we look at fatality rates, according to the Bureau of Labor Statistics, contact with electricity is the 7th leading cause of occupational fatalities. Now we hear a lot about the term arc flash, which is something very, very important to us and can be, causes great injury. But if we look at 95 to 98% of the folks that get injured in the electrical industry today, generally we're looking at shock as well. So it's something we can't ignore. Shock is probably the primary thing we need to focus on along with arc flash, electrical shock and arc flash, as well as thermal burns. Of course, not all of these injuries cause fatalities. When we look at the person in the hand in the upper right here on this picture, we can see that this is actually from an electrical contact burn. So this gentleman reached into a junction box to pull some wires out of the junction box, and next thing you know, he can't move, he can't say anything. He is stuck there on the electrical circuit. And what happened is the wire was stripped too far back. It was sticking out of the wire nut or wire connector, and he was laying across metal. So what started out as a small pinhole in his skin actually ended up over the next week or so looking like this on his hand. It actually cooked his hand. So in other words, part of his hand, the electricity flowing through it, cooked his hands. Now generally when I do a training class, I'll ask folks how many people have been shocked. And probably 99% of the people in the class, or typically sometimes even 100%, raise at their hand that they've been shocked. Now, usually we'll get a handful of people that have been hung up on electricity, although some people that have been hung up on electricity aren't there to speak about it. So, of course, we also have to deal with arc flash hazards. On the upper left, you see a cabinet. This is actually a adjustable speed drive that actually went up, had an arc flash event, a medium voltage adjustable speed drive, had an arc flash event. Now, the technician that was operating the drive actually had the door closed. And the door was closed when he was operating it, and if he didn't have PPE on, he would have been injured. Now you can't see it because the picture, I had to make the picture white. The picture was actually very dark, and I had to brighten it up and adjust a little bit so you could see inside the drive. But this drive, again, the walls were blackened, everything was blackened around the drive because even though the doors were closed, the arc came up through the vent holes. Now, one of the points I want to make, when you're looking at a PPE program, even NFPA 70E says in some cases closed doors do not fully protect against arc flash. So we have to consider closed doors, open doors, the arc flash. We might have a closed door, but that doesn't mean we're not going to have an arc flash. On the upper right, you see a picture here, hopefully you could see my mouse pointer here, but you see a picture here of a arc flash that occurred, and this occurred in electrical switchgear when the disconnect was opened up. It occurred on the line side of the fuses here, and there was an arc flash, and it did blow the door open. So the gentleman here did get exposed to the heat and did get a level of burn, even though the door was closed at the time that he was switching that circuit. On the lower left here, we see a busway, and there was a bus plug in that busway at the time it exploded. And the gentleman, no one was working on it, but the gentlemen that were standing in the room, 3 of them were standing about 10 foot away from this, actually said the flames came out to just about where they were standing. Fortunately, no one got hurt, but they were, no pun intended, totally blown away that they weren't even working on it, and the arc occurred, and the flames came out so close to where they were standing. So they do infrared scans on this once a year. Now they're going to do these infrared scans every 6 months to try and help avoid something like this. They don't know the actual cause of this explosion. On the lower right, you can see this is where a gentleman opened up a piece of switchgear. He opened up some switchgear, and there you can see the ground wire is sitting about an inch away from the busway there. And by the way, this is energized. It's burned off in the past, and he's fortunately in a full arc flash suit. But prior to this, he had been off for a while off work, because prior to this he was not an arc flash gear, and he was doing some work on equipment and was involved with an arc flash. And unfortunately, that arc flash caused his clothing. He was not wearing arc rated clothing, caused his clothing to be burned, caused him to get a burn, and his clothing to burn and melt to his skin. He was wearing a synthetic fiber clothing, and of course he had to go through a lot of skin grafts and very painful time of recovery and healing. So we'll talk about the fact that we do not wear any type of synthetic fiber clothing unless it's non-meltable and meets the standards. So we can have arc flash and arc blasts. So we can have arcing faults, can release dangerous levels of radiant heat energy, which can cause our clothing to ignite, or melting can occur. We can also have an arc blast. So if we look at the picture on the right side there, we see an arc flash, but we also see the gentleman being blown back. You may have seen this video. It's available on YouTube. This was at a meat packing plant, but the gentleman's blown back. So when we look at PPE, we also have to consider that PPE protects us against heat, but it does nothing to protect us against being blown back. In other words, the blast pressure wave may cause internal injuries, and or it may cause us to be blown back against something that's sitting behind us. So one of the key things to even think about here is when we're doing energized electrical work, depending on the level of magnitude of incident energy, where are we going to be blown back to? What's behind us? Because our PPE is not going to protect us there. Maybe a hard hat would help protect our head to some degree, but again, we could fall back against a sharp object. So we need to think about that. So we have potential burn injuries. We have potential injuries that are associated with the arc blast. We could have hearing loss, so that's why we have to have hearing protection. Lung damage if we don't have the appropriate protection on, such as we're wearing a face shield and a balaclava at too low of or too high of an incident energy level. We can have damage to eyesight, physical injuries, and lung damage. Well, I already mentioned that. So now, as I mentioned before, we should have an electrical safety program. I believe I mentioned that we should look at PPE as part of an overall safety program. NFPA 70E calls for the employer to implement and document an overall safety program, and that program must be appropriate for the risks associated with the electrical hazards. Now, I reviewed many safety programs and developed these over the past, and in reviewing many safety programs for clients, one of the things that I could say is that the safety program must provide us with information that helps us determine what is the policy and what are the practices and procedures for selecting PPE in our organization, at our facility. Many times I review a safety program that says it just refers folks out to NFPA 70E or to OSHA, but then we're expecting folks to go out and dig that stuff out of the standards. Well, how many folks are going to take the time and fully understand and go on to OSHA, the OSHA or state OSHA websites, and go on to look up fully NFPA 70E? Now, I realize folks should be trained in this, but also we want to make it clear in our safety program what's required on our site and in our organization. And sometimes that can be a little bit different. So our written program should include the OSHA requirements and also include elements of NFPA 70E in the workplace that are tailored to your facility and to your work. And I've given you a few examples that we should make sure we have electrical lockout tagout covered, or at least make sure, even if it refers to electrical lockout tagout in a general controlled hazardous energy lockout tagout program. We should also make it very clear that folks that should be trained to perform a job hazard analysis or risk assessment. And this is a key thing I'll mention several times today. In many cases, we want to have a paint-by-numbers approach. We want to tell everybody, well, if you put on level 2 PPE, if that's what's called for, you're good. You're good to go. Well, I want folks to understand, to be able to make risk assessments and do job hazard analysis. So if we walk up to a piece of switchgear, we can decide what level of PPE is necessary. We can make good, educated decisions. You'll find that both NFPA 70 calls for a risk assessment and OSHA calls for a job hazard analysis. So it's up to us to have enough information and knowledge that when we're looking at our PPE and selecting our PPE, that we can make good, educated decisions on what level of PPE that we're going to wear. And I'll talk a little bit more about that as we go through this. Of course, work practices and procedures, job planning, training requirements, these are just a few of the basic elements of a written safety program. But as mentioned, personal protective equipment should be covered in that electrical safety program, that written program. Items such as selection, training, what are the training requirements, application, the maintenance of the PPE, which I'll discuss as we go through here today. It's absolutely critical that we properly maintain our PPE. I can't tell you how many sites I go to do an audit, and I find that people have a certain type of PPE, a treated fabric, that are taking home the fabric and laundering it without paying any attention to the types of detergent that need to be used. So in essence, in many sites, they're laundering out their treatment and not knowing that it's gone. So we've just, in essence, blown our PPE program right there with that one simple error. So demonstrations of knowledge and limitations of PPE are all things that should be covered. In other words, do we have folks demonstrating their knowledge of PPE? We can provide training to them. We can make sure that we hand them a bag of PPE, but can they demonstrate? Can they go up and read a label, explain what that label means, the incident energy, and explain what working distance means, and actually be able to say, here's how I go about picking my PPE, the thought process I use to select my PPE. I would highly suggest, if you have folks that, that have PPE out there, that you maybe ask them a few questions about how they go about picking their PPE. I'll never forget one audit where we brought in 20-some people into the room, and we did this in a classroom. We brought them in one at a time, and we had their PPE, forms, everything. They were warned they were going to go through this, a picture of the arc flash label and the gear, and we asked them to explain to us how they would go about picking their PPE. Out of these 20-some people, only 2 people got partway through it satisfactorily. They could not explain their PPE, how they picked it, the limitations of the PPE, the maintenance of their PPE. Now, what did that tell me about their training program and their written program? Definitely work was needed there. So on the right, we can see here that this gentleman is obviously not demonstrating a successful or understanding of selection, application, and use of PPE. If anything, this gentleman is demonstrating what not to do. I want to touch a little bit about OSHA standards, because this is the language here is important to us. Again, OSHA is law. So OSHA regulations were developed to mandate that employers provide a safe workplace. We have sections of 1910, which deals with utilization, and subpart S, utilization for electrical. Of course, we have power generation, transmission, and distribution. And 1926, which focuses on electrical construction. So promoting the safety of employees working on or near electrical equipment and defining employers' responsibilities. Now, there are a lot of helpful resources on OSHA.gov website, interpretations and resources that you can find, including a brand new publication on recommended practices for safety and health programs. So there's a brand new document that was launched just in October that you might want to download on the federal OSHA website. Now, of course, individual states may have their own programs which can modify federal OSHA requirements. However, these requirements can never provide for a less stringent requirements. They can never relax the requirements. They can enhance the requirements or modify them as long as they provide for the same level of safety. So if you're in a state that has its own state OSHA program, please go to the state OSHA program. But even if you are in a state that has its own state OSHA program, you can find many helpful tools and resources on the federal OSHA website. So in talking about OSHA here and looking at it, we have 1910 subpart I deals with personal protective equipment, the requirements, use, and training. Now electrical PPE is also discussed primarily in subparts S, R, and K. So we have subpart S, utilization, wiring design, safe work practices, methods, electrical lockout, tagout, and of course electrical PPE is discussed in subpart S as well. You have subpart R, special industries, such as power generation, transmission, and distribution. And this is a very important standard. If you have cogeneration on your site, or if you have medium voltage distribution, or if you have tunnels, if you use live line tools, or if you use grounding practices when you use control of hazardous energy, your control of hazardous energy program, if you use grounding practices, these are all things that are covered in subpart R. So anything, and there's some gray area there, but when we look at medium voltage distribution or on-site cogeneration, I'm not talking about backup generation, I'm talking about cogeneration, you're going to see crossover the requirements. Even though you may say, well, I'm not a utility generation facility, that's okay. OSHA recognizes industrial sites and sites that have on-site cogen and other medium voltage distributions, things that look more like a utility system, as requiring specific work practices and regulations. So you will find those in OSHA subpart R. They will also cover the specific requirements for picking PPE in outdoor substations and overhead lines, and the types of calculations that are allowed for determining your PPE in those environments. Now, OSHA's 1926 subpart K gets into safety and health regulations for construction and dealing with electrical. Now, those are much less stringent than utilization. However, it would be good to become familiar with those requirements as well, as many folks also will be involved with construction on their sites. So let's take a look at what OSHA subpart S says. Okay, OSHA subpart S for utilization system says if equipment cannot be de-energized prior to work, employees must be properly protected. Now this is what I call one of the blanket requirements in OSHA. That language is very, very broad. So let's look at here. When employees are required to work where there's a potential electrical hazard, it doesn't say there is a hazard, but a potential electrical hazard. 335 calls for the employer to provide electrical protective equipment that's appropriate for the specific parts of the body to be protected and the work to be performed. In other words, they're telling you it's up to you as an organization, it's up to you as an employee to assess the hazards, assess the risk of injury, and make determinations on what level of PPE is required. Now, the appendix in 1910 does reference 70 as providing information that could be helpful in understanding and complying with the requirements contained in subpart S. But it doesn't guarantee you that folks won't get hurt if you're following the requirements in 70E. And it doesn't also say you can't get cited if someone gets hurt following the requirements in 70E. Now, many OSHA enforcement personnel use NFPA 70 as a reference tool to help determine whether you're in compliance with the OSHA requirements. But there again, you could still get cited if someone gets injured, even if you were following NFPA 70E. Again, the thing that we're supposed to look at here is it's up to us to make risk assessments. It's up to us to determine what's appropriate PPE. NFPA 70 provides guidance, and very good guidance, but we have to make good, educated decisions. So looking at NFPA 70E, the standard for electrical safety in the workplace, the document is a very, very powerful tool that we can use. We're going to take a look at some of the requirements out of Chapter 1, work involving electrical hazards. It's very important we properly maintain our equipment as well. If we have breakers that aren't clearing in time or equipment that's not properly maintained, we're going to have a much greater risk of injury and also possibly much higher hazard levels that we could be exposed to because our breakers are not clearing fast enough to give us the incident energy that we were assuming in our calculations based on the manufacturer clearing times. We can also have safety-related maintenance requirements that are addressed here that also refer you out to NFPA 70B and other NETA maintenance requirements and special equipment that are also covered. We also have annexes that get into publications, examples, sample procedures, and so forth. Probably pretty sure that most everyone on this presentation has that standard and is aware of those requirements. Now, again, if we look, I've been mentioning a risk assessment, but NFPA 70E calls for the electrical safety program, your electrical safety program, to have risk assessment. So the risk assessment addresses employee exposure to the hazards and identifies the process to be used by the employee before work is started to identify the hazards, assess the risk, and implement risk control according to a hierarchy of methods. So again, it's up to each individual. As I still go in the field and work today, I still wear the arc flash protective gear. So we're not just talking theoretically here, but every time I look at a piece that's electrical switch gear or a motor control center or something like this, what I'm looking at is I'm making an assessment. Is this equipment properly maintained? What does the installation look like? How old is the installation? Are there vent holes in the covers? If I'm going to switch a 1200 amp breaker on, even with the covers on, I may be standing in front of a bunch of vents and may say, I'm going to make the assessment here that the arc flash energy could come out through those vent holes if something goes wrong, and I'm going to go ahead and wear the full PPE as if I was doing this as if the doors were closed, or open, excuse me. So, again, each person should be able to make an assessment. Now, I get so many people that want to turn this into a black and white thing. In other words, we have to do this here or we don't have to do it here. No, it's up to each one of us to have enough information to make judgment calls. And I'm just going to show you an example, and I mentioned shock protection early on, but here's a site where we did a risk assessment. And a lot of times people forget about production equipment when they talk about risk assessment. So, in other words, they're talking about, we went out and we assessed our motor control centers, our switchboards, our panel boards. We put arc flash and shock hazard warning labels on it and so forth. But yet you get over to the production equipment, and here we have a technician, maybe that's only working on 24 volts in that cabinet. This on the right we can see here's from a power supply, and I've got a red arrow there. The technicians were only trained to work on 24 volts, and they weren't even aware there was 480 volts in the cabinet. Now, there should have been a sticker right on that cabinet indicating 480 volts, the source. And when you get into the power supply, if you look very closely, and again, it's much brighter here because I've changed the picture a little bit, but you see at the input on the lower right of that picture, it says on the right there where the red arrow is, it says 400 to 500 volts input in a non-finger safe terminal block there. They weren't even aware that 480 volts was in the cabinet, yet they were working barehanded. So again, this is a violation of OSHA, the OSHA requirements, and NFPA 70E. As we see folks working, they should fully understand what they're working with, assess the risk, and make good educated decisions on how to protect themselves. On the left, on the lower left there, you see a site where you have a plastic cover. Now, this plastic cover may help protect against someone making direct contact from a shock perspective, but if something falls down behind that cover, we can still have an arc flash event. So our risk assessment would tell us it's still very important for us to provide arc flash protection. Anytime, and a lot of times when we get into equipment, we ignore the fact, we think of arc flash as being, okay, at the face and chest. Maybe I have 1 calorie at 18 inches working distance away from the point of where I'm working. So in other words, I may not have to wear any arc-rated clothing on my body because we're looking at the 18-inch working distance. Yet my hands, even with gloves on, part of my arm may be much closer. In other words, it's 1 calorie at my chest, but what is it at my arm? And I'll have a slide coming up where we'll talk about that further. We just had a gentleman here not too long ago was working in gear. The incident energy was 0.7 calories at his chest. He decided to wear PPE, and you should see his clothing at his arms and his gloves. Very significant black marks. And we calculated the incident energy there, and it was well over 25 to 30 calories at his gloves, and at about 7 to 8 calories back at his arm. So, again, just thinking about the face and chest, this is where we have to have folks think about what they're going to do and what kind of protection they need. NFPA 70 Informative Annex F goes into, risk assessment. So I would highly recommend that you got to make sure you open up your copy and open up to Informative Annex F and take a look at the risk assessment process. Not only from a long or a short-term perspective, as far as this perspective, this worksheet we're looking at is more of a longer-term perspective. Because our goal here in a PPE program is not to just put PPE on and expect it to always do its job to protect us. In other words, I guess I probably could have said that better. Our goal is, let's not even have to wear the PPE. If we can figure out a way to do something better, to get things shut off, external test ports, external infrared ports, things like that, because PPE really should be our last line of defense. So PPE, we want to look at that. That is one of the methods to protect ourselves, but even if we wear PPE doesn't mean we won't get injured. So let's try and figure out ways through doing risk assessments that we can avoid having to even put the PPE on. And in this next slide that comes up here, we can see this is from the hierarchy of health and safety controls, and this is adopted from the AIHA standard Z10 for occupational health and safety systems. You can also find information on job hazard analysis in OSHA 3071, publication 3071, and of course in NFPA 70 Informative Annex F. But really, we want to be operating at the top of this hierarchy. In other words, our goal is to eliminate exposure to the hazards. Now, generally, we're always going to use a combination of all 6 of these items, from elimination, substitution, engineering controls, warnings, administrative controls, and PPE. But PPE should be considered our last line of defense, and it's also considered least effective out of all of these 6 items. It's considered the least effective. So the point I'm trying to make here is, let's figure out how we can bring our energy levels down. We've got great tools today with the software, with Easy Power software, and great tools that we can use and great equipment out there. Let's figure out how we can bring energy levels down, or the risk of injury down, not just throw on the PPE and hope it protects us. So just some examples of reducing exposure and risk. On the left, we see an external test port. Now we have an actual voltage test port here, and this is from Grace Engineered Products here on the safe side. On the right side of this device here, you can see where you can actually plug in test leads. So we can put this external to a piece of equipment. Actually, if we're doing lockout, tagout, let's say, we can shut off the device, test it without ever having to PPE up. So we would verify that we have voltage, shut it off, verify the voltage went away, and then we probably would be able to open the cabinet depending on the type of cabinet and so forth. And again, I can't say this in a blanket statement for all equipment, but this is one of the ways to help even having to put the PPE on to verify zero energy, is having a disconnect in a separate cabinet or enclosure with a test port. Now, of course, if we have voltage at the top of the breaker, anytime we shut off the breaker switch, if there's voltage still at the top, the PPE still stays on if you're going to be within the shock or arc flash boundaries. On the lower left, we see a load-rated pin and sleeve connector here that could be used for disconnects. Now, we'd still want to, for my recommendation would be, to still shut off the load before you disconnect this, but these are load-rated just in case someone did disconnect it under load. On the upper right, we see an infrared port, an external infrared port, and on the lower right, we see a remote rack-out device. These are all things that we can do to help protect ourselves against being exposed to the hazards that we might be exposed to in the workplace. Of course, training requirements come into play when we talk about PPE. Qualified person, so we look at the definition in 70E, shall be trained and knowledgeable in the construction and operation of equipment or a specific work method, and should be trained to identify and avoid the electrical hazards that might be present with respect to the equipment or work method. Now, a qualified person must also be familiar with proper use of special precautionary techniques, applicable corporate policies and procedures, personal protective equipment, which is what we're focusing on today, the hazards, insulating and shielding materials, insulated tools, and test equipment. The key thing over here is that a qualified person also requires demonstrated skills and knowledge. And I mentioned that early on. We need to make sure that our folks can perform risk assessments and or hazard analysis, and that they can make good educated decisions, and they could demonstrate their knowledge of picking, selecting, care, application of PPE. Of course, we have the shock boundaries. and that shock risk assessment has to help us determine which voltages the personnel could be exposed to inside the gear, the boundary requirements, and the PPE necessary to minimize the possibility of shock. We have the arc flash risk assessment. Again, when an arc flash hazard exists, that's the distance away from the prospective arc source at which a person could receive second-degree burn. And generally you see when we exceed 1.2 cal, the requirements there. So we'll look how far back from the potential arc source does the energy level drop off to 1.2 cal, and at that point PPE is required. Now anyone within the arc flash boundary must wear appropriate PPE. However, it's very important to realize that protective device clearing times, short circuit current variations, etc., can impact that boundary. If it takes longer for our breaker to clear our protective device, the boundary could be further away. Also, we have to realize that standing right outside that boundary, inside the boundary's onset of second-degree burn, this is not a magic boundary. In other words, there's no force field shield that comes up with that boundary. Standing on the other side of the boundary, you still may definitely hear the blast. You still may be exposed to shrapnel. You still will probably be exposed to a level of heat. So an arc flash risk assessment is called for. One of the following methods shall be used for the selection of PPE. Either but not both methods are permitted for PPE on the same piece of equipment. In other words, we can take a piece of equipment and we can use one method or the other. Now we can use both within the same facility, and that may be where we have a facility where we don't have a study done yet. So part of a facility, or a facility we haven't even completed the study done yet. We have the incident energy analysis method, which is the calculation method. That is the preferred method because now we're getting the actual incident energy on here. Now on the right, you can see a label here, and the label indicates 4.9 calories at 18 inches. And you can see it also indicates a PPE level. You will not find, though, however, on my labels, you will not find the list of PPE on there because the PPE in many cases changes over time. And we will use a separate poster in a facility to indicate PPE, a visual poster. In many cases, for many clients, we're leaving the PPE level off as well. And why is that? Because if we're at 7.9 cal and we indicate level 2 in a facility, or we may call it in many cases if it's a facility custom PPE level A, B, or C, we don't want someone walking up and saying 7.9 cal, but ignoring that, just putting a level 2 on. I'd like them to see the 7.9 cal and be trained to understand, whoa, maybe I should wear something a little higher than 8 calorie here because of all the variables involved here. In other words, if we look at the ATPV value of PPE, if we look at the clearing time of the breakers, the age of that, all those things, I want people to think about what they're wearing for their PPE, not just put stuff on without thinking about it. Of course, the key thing, if we're going to do a study, is to develop a game plan. Our goal of our game plan is not to just calculate what we have, it's to really reduce energy levels, analyze multiple system configurations, and also make sure we identify underrated equipment that's not rated for the fault duty. Otherwise, we don't even know whether the breakers are going to clear, if they're going to clear in time. We also need to assess the level of maintenance. Have the breakers been properly maintained and so forth? So it's very important we develop a game plan, not just calculate what's there and throw the stickers out there, but we develop a game plan trying to bring energy levels down. If for some reason our calculation is off, if the formula is not perfect or our calculation method is off, I'd rather have it be off at 4 calories and maybe we have 6 calories or 7 calories, even though we calculated 4, than have it be off at 35 calories, where we're now seeing 50 calories because something was not correct in our calculation. And I'm not saying an error the way we do our calculation, but there are variations in formulas, again, in the clearing time and so forth, which we'll talk about more as we go through. Okay, so if we do the calculations, then we will go through and pick the PPE from the text of NFPA 70 Article 130. So we use the text in there to pick our PPE. Now the text is summarized in Informative Annex H in the back. And I've only put up one of 3 groups of the PPE in Informative Annex H, but if you have greater than or equal to 1.2 to 12 calorie, this gives you the requirements for PPE. There's another group less than or equal to 1.2 cal and another group for greater than 12 calorie with some different requirements in there depending on the energy level you're exposed to. a very good approach to a three-level system. Again, when we look at three levels, the lower level may be all natural fiber clothing, which is not arc rated, but allowed per the standards for that level of exposure, up to 1.2 cal. So 3 levels, pretty simplified approach. Again, we want to look at, we'll have an example of a poster here in just a few minutes. So if we're going to do the calculations, then we can look, now we could have 4 levels of clothing if we want. We could bring this down to 2 levels. Okay, and I'll talk more about that. So it's up to us. We get the option. Again, 70E is giving us guidance, but we can make educated decisions. So we don't want to go provide for less than NFPA 70 is calling for, but we can always go above and beyond or change the PPE into different groups. So for some organizations, we have one group up to 12 calorie exposure, 10 calorie, and another time when we go above 10 calorie, we have another group of PPE. Okay, within NFPA 70E, there's what's called the arc flash PPE categories method. So depending on the type of task that we're doing, or work location, and of course there are certain limitations to using these tables. The short circuit currents, the clearing times, these are all things that come into play when we're looking at selecting our PPE. Now the challenge with this table is so many people want to go in and grab that table and use that table without paying attention to it. Now this is better than doing nothing. But again, we have to make sure that our short circuit currents do not exceed those if we truly want to use this table. And that's what clearly laid out in the notes of the table. The working distances, the clearing times for the breakers and so forth. And by the way, if you think about clearing time, arcing current may give you a longer clearing time. In other words, if we look at the maximum fault clearing time, if you have an arcing current, for example, at 480, the arcing current may be a fraction of what the actual bolted fault current is. So if we look at a typical example, we may sustain an arc down to 38% of the bolted fault current. So I would look at the clearing time and say, okay, if I have a 10,000 amp bolted fault current, I may only have 3,800 amps of arcing current. Is that going to still be within the instantaneous trip range of my breaker to get my 2-cycle clearing time on my, let's say, molded case breaker? So it's important we do pay attention to that. But the key thing is here is don't wait for your study to be done to wear PPE. Start somewhere. Start, if you need be, in the tables, and start today. Because the longer we wait, the more possible we expose someone to one of these terrible, terrible arc flash incidents. So again, they also give you, a table and kind of indicate whether arc flash PPE is required. By the way, look at the top item there. Perform infrared thermography and other non-contact inspections outside the shock boundary. Not the arc flash boundary, the shock boundary. Now the person opening the covers would have to wear PPE because that's called for in the standard, but here we can have someone standing maybe right there in the range of 30-40 calories and not wearing any PPE because it's considered a low-risk task. Okay, PPE may not be required. Well, you may say, well, yeah, a person standing there holding a camera, they're not disturbing anything. Anybody in this webinar, I'd be curious. I'll bet some of you have had, contamination, dust, something fall down, even when no one's working, a rodent climb out of gear. Let's think about that from a risk assessment standpoint. Let's not blindly just follow what the table says. The table also does give us notes that indicate that it's important for us to perform a risk assessment. It indicates that arc flash, even though it indicates an arc flash PPE is not required, that doesn't mean an arc flash won't necessarily occur. Again, it's up to us to perform risk assessments to make those decisions. If I have someone doing infrared thermography on my site and the gear's open, they're going to be in a level of PPE. We may have them calculate the value a distance further away so they don't have to wear as much, but that's just my perspective on this. Of course, then we go into the table once we determine, the type of task we're doing, and then we can look at the location. We talked about that a little bit earlier. We can look at the location, whether we're within the fault clearing, the maximum fault short circuit current values, the clearing times, and the working distances. Then that gives us a ballpark PPE category and a ballpark arc flash boundary as well. And these are just examples. There's a lot more information in NFPA 70E. And then that takes us to, 4 categories of clothing. So PPE category 1, 2, 3, and 4, we could just make that into categories 2 and 4, which is what I generally suggest. There's no need to have 4 levels of PPE. Level 1 is going to cost you about the same and be about the same fabric weight as a level 2. Same thing with a level 3 versus a level 4. Okay, and again, pay close attention to these tables. If you use the table method, if you look on PPE category 1, it says an arc-rated face shield. C note 2 says you have to have side shields and chin guards, but it doesn't call for a balaclava. Article 130 says if, and 130.1, section 130.1 says all requirements of the text apply whether you're using the table method or whether you're calculating the incident energy. And the text says when the back of the head's within the arc flash boundary, you have to wear PPE. Many people have trained themselves to turn their head to the side when they switch a breaker on or a system on or off. So think about that. Did we just possibly put the back of our head or the side of our head in the arc flash boundary and we have no balaclava on? Again, this is where it's important for us to perform risk assessments. Okay, so there are many different things that we can look at in the tables. If you're at a site where you have power generation, transmission, or distribution, a cogen like I mentioned, or you are a utility with a generating plant, then you're going to want to look at the OSHA requirements. So we have a new OSHA requirements released in 2014 from federal OSHA, and now many of the state programs have adopted their requirements as well that should be very similar to the new power generation, transmission, and distribution. But the requirement here is the employer shall assess the workplace to identify employees exposed to the hazards from flames or arcs. Now, you'll notice they say flames. We might have hot flaming oil coming out of a transformer or substation. So it's important you become familiar with these regulations as well. And it's important, it also calls for each employee exposed to the hazards, the employer shall make a reasonable estimate of the incident heat energy which the employee would be exposed. Now, when we look at, again, 1910-269, we can see Appendix E provides guidance on estimating available heat energy. For example, we wouldn't use IEEE 1584 above 15 kV. We'd go into the informative or Appendix E of the OSHA requirements, and it would tell us which types of calculation methodologies would give satisfactory results. For example, for calculating 46 kV, the incident energy in a substation. They also have some tables in there that can also be used for picking PPE and so forth. Now again, we can always go beyond this. In some cases, this is less stringent than what would be called for in NFPA 7E. In some cases, there are additional requirements that go beyond NFPA 7E in protecting, again, flames and so forth. So it's important. Also, as I mentioned earlier, if you use live line tools or anything like that, please become familiar with this standard, because the requirements for grounding, live line tools, control of hazardous energy can all be different when you get into substations, underground, or overhead medium voltage distribution, and cogen, etc. By the way, some sites are actually indicating that if you have on-site solar, they're actually treating it as continuous power generation. Okay, so when we look at electrical PPE, I'm going to suggest you limit your PPE to 2 or 3 groups. So an example of that, and we talked about 4 categories, 4 levels in the PPE levels method. There was 3 levels that we talked about for if you do the calculation in the informative Annex H. But where you have limited frequency of exposure, in other words, someone may work most of the day and not open up or be exposed to electric arc or open up to cabinets, get in work in cabinets, consider wearing all natural fiber with other appropriate PPE. And then maybe as the day goes on, you add PPE. In other words, you're going to open up a cabinet, maybe you put on your 12 cal coveralls and your 12 cal face shield. And the reason I mentioned 12 cal, and so you can add up to 8, 10, or 12 cal, I always want some headroom in the ratings. Why? Because we'll look at the ratings of this, but the face shields, if we look at the standards for face shields, 2178, and the standards for clothing, it's rated at 50% probability of onset of second-degree burn. So you do not want to push your PPE to 100%. So I may take an exposure up to 8 cal and have folks in 10 or maybe even 12 cal gear. So you could add up to 8, 10, or 12 cal system, or maybe up to level 2 PPE, or you could go 40 or 40 plus calorie. Now some people say, wait a minute, 40 plus, we're not working above 40. Well, there's nothing in the standard that prevents us from working above 40 cal. although we generally do not do that. I will not work above 40 cal personally, but I can have just as high a blast at 39 as I can at 41, depending on the type of system. I could have a higher fault current, a shorter duration, giving me 39 cal, giving me just as big a blast, but I am not promoting working above 40, but what I am saying is you might want to consider additional protection above 40, like consider wearing a 65 cal suit. And I'll talk about why that's important here in just a little bit, if you hang with me. Okay? So you could wear, just put on a 10, 8, 10, or 12 cal system, or go up to a 40 or 40 plus cal system, or you might want to just wear 8, 10, or 12 cal all day long with like shirt and pants, and then put on the extra PPE like the face shield and so forth, or increase to 8, 10, or 12 cal system, whichever, wear an 8, 10, or 12 cal system, and then increase to 40 or 40 plus cal PPE as you get into the higher exposures. So generally we want to keep this simple, the program simple, and we want to make sure people, again, understand it. The less complex, the better. Okay, and it's important to understand that NFPA 70 says clothing and other apparel made from materials that do not meet the requirements for melting or the requirements for flammability shall not be permitted to be worn. In other words, up to and including 1.2 cal, it can't be melting. Above 1.2 cal, non-melting and also non-flammable, arc rated. Okay, so, and that goes for, you know, even for undergarments and so forth. So as we look at this next slide here, we see that, you know, we do not wear meltable garments underneath our arc-rated garments or underneath even our all-natural fiber garments. The possibility is that we might have those garments melt to our skin, and we have seen this in the industry. There's actually one case study that was very unfortunate, but a gentleman up in an AWACS plane wearing his Nomex flight suit, which also doubled as his arc flash protection. He was wearing his moisture-wicking undergarments, which were meltable, which were not. All natural fiber, didn't meet the standard, didn't think about it that day, and it melted to his skin underneath his Nomex flight suit. So a year and a half of skin grafts and an honorable medical discharge. Now you can, again, wear undergarments that are arc-rated if you want to help provide additional protection. All natural fiber undergarments can help limit heat transfer through to your body, but cannot be added to the arc rating of the clothing system. For ladies, there are ladies' undergarments that are available in arc-rated fabric, because it's kind of hard to find natural fiber garments. So if I give you just kind of a pictorial here of a quick reference, if we look at the different sections of NFPA 70 2015 of what's required, and I'm not going to read each one of these, but you can kind of get a quick pictorial of what is allowed now or what's required depending on, this is an example for what you would typically call level 1 or level 2 or up to 12 cal if you do the calculations. Now I would probably stop this at 10 cal just to allow for more headroom. And again, if we look at outer garments, they also need to be arc rated as well. So this would be, it could be shirt and pants or coveralls, as I mentioned earlier. They also make, by the way, arc rated hairnets and beard nets that are available. So if you have to work in an area where a hairnet or beard net is required, this is something that you should look at, because the hairnets and beard nets can burn and melt very easily that are not arc rated. Okay, as the next slide pops up here, we can see that an arc flash, in other words, PPE levels 3 and 4 or greater than 12 calorie. Now for me, I wear a hood even down at 6, 7, 8 calories. I start wearing my hood. I actually prefer my hood. With the new air systems, the fresh air systems, and the anti-fog and the newer lighter lenses, this is showing the older yellow lens, but a previous slide I think I showed the lighter lens system. You can now see much easier, even in a 65 cal garment. It's very easy to see. You don't have the color issues you do with the older yellow lenses, but I prefer the hood, easy on, easy off, don't have to have the balaclava sticking to my skin. It's a matter of personal preference, but when we get above 12 calorie, the calculated values, the full hood is required, and also when we're in levels 3 and 4. And again, I would skip level 1, go to 2, and then have level 4, or have a 10 cal, and then maybe a 60 cal, 65, 70 cal system, or 100 cal that's used up to 40 cal. And again, I'm not promoting you work above 40 cal. I'm just saying that you can wear additional PPE, and we'll talk about some of the things related to that, why I think it might be important to you. If you wear outer garments as well, you need to make sure if you're going to wear arc-rated clothing or even all natural fiber and expose yourself to a potential arc, you want to make sure your outer garments are arc-rated. The reason being, you might say, well, I'm wearing an arc-rated shirt. Why do I need to wear an arc-rated high-vis vest? Well, the high-vis vest may not provide you a lot of protection. It may be only rated, let's say, 4.5 or 5.3 cal. But the high-vis vest is made of such a material that it will not continue to burn and melt and drip all over your body. It may after an arc. So in other words, a standard nylon polyester vest will probably catch on fire and be melting and burning over the top of your shirt. Your arc-rated shirt was never designed to protect you against that. It's designed for the short-term arc. So let's not compromise our system by wearing non-arc-rated clothing. And I see it all the time. People wearing hoodies, polyester cotton hoodies over the top of their arc-rated clothing. They're compromising their protection. And in many cases, they may not have hardly any protection because that type of hoodie will just catch on fire, burn, and melt. Anytime you look at PPE, there are many selection considerations. We have to be properly labeled. And just give you an example of the label here. You want to make sure that the garments also meet all the referenced OSHA NFPA 7E standards. And we have a lot of garments coming in from a lot of different locations, a lot of manufacturers. I myself personally prefer USA manufacturers, but that's a personal preference. But all I do want to do is make sure whoever you work with is a reputable manufacturer that you actually can see some of their test reports, especially if you get into the arc flash suits. I want to see copies of the test reports indicating that this garment complies with the ASTM requirements. So please pay attention to who you're using and what garments you're picking here, because there is a difference. We have seen it. We have seen garments coming in from even some locations, some countries that just were not providing a level of protection, throwing them into an arc testing laboratory, and they were not functioning properly. So very important we pay attention to this. Okay, in PPE selection considerations, and we're kind of running down to the to a close here, but we've got about maybe 10 more slides here. But one of the key things in looking at your PPE program, again, I want to make sure people are aware of it. On the right, you see an arc flash warning label, but notice this says 4.9 cal at 18 inches. Well, if I cut the working distance in half, let's say I have about 9-10 inches back to where my glove is on my arm, and I'm working in the cabinet, the incident energy at my arm was going to be somewhere between 3 to 4 times the value there. So in other words, I'm going to see just under 15 to just under 20 cals of incident energy. Well, if people just walk up and say, oh, this is level 2 PPE, well, that's an 8 cal system here, and I'm good. I won't get hurt. Well, we're looking at face and chest. Yes, at your face and chest, you might be good, but on your arms, I want you to realize you might have exposure to 15 to 20 cals. You're not going to be fully protected, so you should make an educated decision. Maybe you throw a coat on, maybe you put a higher level of PPE on, maybe you choose to do nothing, but I want you to make that decision. And again, this is where a program should, help people understand the differences of working distance and so forth versus incident energy exposure. This is, again, where I try and avoid a paint-by-number system. Even though we want it simple, I want people to make good judgment calls on their PPE. I mentioned earlier about protective device clearing time, and even changing breaker settings can impact the incident energy level. So we might go from a 3-cycle clearing time to 2.2 cals in a particular calculation at 23.6 arc flash boundary, and if someone changes the setting on the breaker or the breaker type or fuse type, we might have a significant higher level. So again, people need to be aware of that and how it affects their PPE. Changing transformer types, anything that changes the impedance, changes the fault current, the clearing times, working distance, etc., can impact this, and people need to be aware of that when they're determining their PPE levels. There are also studies that show even depending on how the bus is oriented in the gear. In other words, if we have bus oriented on the side, and this is from an article, you can do a Google search on this maintenance technology article, but if you have bus work sitting oriented on its side, as we might see when we're plugging in an MCC bucket or racking a breaker in versus flat bus, we can have a difference in the incident energy versus the IEEE 1584 values. Okay, and so if you download this paper, you'll see some information on that, So I'm not going to spend a lot of time there, but what I can say is it's important that we make educated decisions on our PPE. I would suggest doing a search on that document and downloading it. Okay. Also, when we look at the ARC rating of PPE, and if we were to look at the label, for typical, let's say, daily wear clothing, so forth, we have the equipment, the clothing is typically rated in ARC thermal performance value. Now, in our heavier garments, like our coats or rain gears or something like that, it's usually rated in EBT. So ARC thermal performance value is the amount of heat. We put 5 sensors on a mannequin, we hit it with an ARC, we measure how much heat gets through, we put a new garment on, we raise the ARC value, we plot the values against the Stoll curve. The incident energy level, the garment is rated at the point at which I get enough heat transfer through to cause 50% probability of onset of second-degree burn. If you don't like those values, go to your garment manufacturer and get a copy of that curve and find out what is that garment rated. In other words, where am I at 2% probability? I would suggest at the very least you allow some, if you don't even have that information, allow some headroom in your ratings. In other words, don't push an 8.6 cal shirt to 8.6 cal. Maybe you only take it up to 7.5 cal. Okay, if you really want to help limit the probability of getting burned. Now, if the garment is rated in EBT, okay, well, I'm going to back up. I'm showing you a picture here of an actual ATPV chart that shows you the Stoll curve and the ATPV here. So again, you can see that you can get this kind of information from the manufacturer, and you can see here that this ATPV was 43 cal, but at 5% probability of onset of second-degree burn, the suit would be rated at about 35 cal. So I would again suggest that you know that about the garments, and it varies per fabric type, manufacturer, so forth. Okay, and I've given you reference standards here as well. Now again, we have some garments may reach break open. I have a ARC-rated jacket. It's a Nomex fleece jacket, and it hits break open because it's so thick and comfortable that it hits break open first before it hits 50% probability of getting enough heat transfer through for second-degree burn. So it is rated at 17 cal EBT. It hits 50% probability of break open before it hits the thermal transfer. So I'm not going to push it to 17 cal. I'm going to push it to maybe 13, 14 calories max. So these are things that come into selection considerations. It's also very important that we label our gear properly and people understand the labeling. So labeling, so when I walk up, I understand what is required. Now, one of the things I want to mention here is in some cases, for example, an automatic transfer switch. We walk up, and if we calculate the incident energy, generally our software is going to tell us the worst case from one source, backup generator or generator, and the alternate source. What if I'm in a transfer switch that has line isolation bypass and a bunch of busing, and the ARC spreads to both sides? So maybe our calculated value with worst case on one bus is 30 cal, but if it spreads to both buses, and now the generator and let's say the utility source are present, and they both get involved with the ARC, what is your exposure there? I would label worst case and then always give a procedure to manage it down to best case. A procedure where you have to go through certain steps and control, for example, maybe you lock out the generator alternate source. So lock out, tag out on the generator alternate source. So again, when we look at labeling, the label, they give us information. We have to put the incident energy of the working distance or the ARC flash PPE if you're using the PPE levels method or category method of 7-E. You can have site-specific levels of PPE also on your label. So you could have a level A, B, or C system, which is generally what we do, so we're not confused with the PPE levels in NFPA 7-E if we're doing the calculations. And then we look at separate posters. So generally what we do is put up separate posters in the electrical rooms and equipment areas so folks can walk right up and see what's required of them. And we replace these pictures with pictures of their PPE so that they can walk up, do a quick visual versus just trying to read a label that may only have part of the PPE on it. And we can easily change the posters out as their PPE changes. So this is what we recommend for a PPE system of, letting folks know what's required in their facilities. And in many cases, we'll tell a contractor it's up to you to do your own risk assessment. I'm not saying that in a negative way. I just don't want someone to go in and make assumptions that they may not fully understand the equipment. Also, when we look, and we have just a couple more slides here, but when we look at battery service, please don't forget about battery service. You know, shock protection, arc flash protection, and if we have exposure, let's say we're working with wet cells, that we have appropriate chemical ratings. There are chemical rated, arc flash rated, and also arc flash rated rain gear that you can use. So you can get chemical and arc flash rated gear if you have exposure to both. So there are different types of fabrics. Again, very important that you pay attention. Treated cotton, again, but I would watch that carefully. If you don't launder that product properly, you can degrade the product, and I would look at the life of that garment. In other words, how many laundries will that garment sustain? One fabric manufacturer indicates their product is good for the life of the garment. Well, tell me what the life of the garment is, how many launderings, and track those launderings if you have a specific time frame that you're looking at. In other words, it may say, well, it's good for 60 or 70 or 80 launderings, then track that and make sure folks are tracking that. Okay, so there's treated cotton. There's also inherently arc-rated fabrics where we don't really generally have the issue of the treatment being laundered out. The flame resistance generally isn't degraded by laundering. It does react a little differently, usually a little less after flame during an arc event, so forth. So personal preference comes into play here, but some of the key things is let's make sure, depending on what type of fabric we're using, we understand the fabric, its limitations, and so forth. Again, make sure that we inspect before we choose. Do not use if damaged or contaminated. Grease, oil, flammable liquids. Always follow manufacturer's instructions, and I've given you some recommendations over here on the ASTM standards for industrial laundering. Make sure your industrial launderer is following the right laundering practices, and this is a very important thing as well. If folks are taking the garments home and laundering it, and it's a treated cotton product, let's say a cotton nylon blend, in as little as 8 to 10 launderings, they can seriously degrade the treatment. Okay, a lot of fabrics say right on the garment, say right on it, do not bleach. Well, if I think do not bleach, I'm thinking of pouring a can of bleach in. I'm not thinking of, you know, whiteners and brighteners, sodium hypochlorite or hydrogen peroxide in, let's say, OxyClean or other garments that are actually a form of bleaches, but yet don't say bleach right on there. They say whiteners and brighteners. If we allow folks to take garments home, it's absolutely essential we have a clear, clean, written laundry program that they're going to follow, guide, and that they understand it following it. I can't tell you how many sites where even after they've been trained, they forget after a while, and then they're laundering the treatment out. So that's why, again, I look in many cases towards the inherently arc-rated garments as a personal preference just because of that. Okay, so summary, PPE is your last line of defense. Take some time to develop and document a PPE program. Make sure personnel are properly trained, understand the limitations of PPE, and always perform job hazard analysis and risk assessment and make PPE determination based on educated decisions.